So with this zip line, we want to be able to draw the zip line out, right? Draw a picture. But we have to understand what each part's saying first, right? So when it's telling you if the zip line is a set of ratios from 3 to 4, what this is saying is that what's the down, what's the up, or what's the down and up, what's the rise and run? You know, when it says 3 to 4, which one would be up or down?
3 would be up, right?
Yes.
Or down.
Or down, right? So the 3 is either going up or it's going down, right? And 4 is either going left or it's going right. Okay? I drew the opposite of what I said, but you know. And so we got to think about, well, think about a zip line. Do you zip line up or do you zip line down?
Down.
That's the first thing you want to think about. Okay. So we know that we have a zip line and we're going to zip line down. Okay? So we're creating this triangle already. And the zip line's going down. And within that zip line, however long that zip line is, there's a base zip line of the up and the down. And that up and down is really 3 and 4 is what we're saying. So what we're really doing is we're going down 3, right? And we're going right 4 in this case. Okay? So what this zip line is really saying is that the slope is equal to -3 over 4. Okay? So that's the first thing you really need to understand. You need to understand that slope is m. Okay? Alright, so on the y equals mx plus b. In order to create the linear equation, you have to know y equals mx plus b, right? So you can write that in. As you're doing this, you just keep writing in your understanding. Right, Aaron? Are you writing it in? You need a pen? Okay. Raisin, you need, or Raisin, Mason, you need some pens?
Alright, but you could give me my pencil back.
There you go. Alright. Now, it says that and now on your paper it didn't say, I forgot the word base of, right? And so I want you to put that in, that the base of the zip line, right? The base of the zip line is 100 feet. That means this piece, okay? So this base of the zip line, that's this whole piece right here, okay? That's 100 feet, okay? From there to there, okay? And it's really important that you have that understanding, okay? And then it says that the end of the zip line is 15 feet off the ground. Because if you're coming down on a zip line, right, you don't want to come down and hit your feet on the ground, right? If that zip line is less than 6 feet, most of you are going to hit the ground. Why is that? Even if it's less than 7 feet, most of you are going to hit the ground, right? Why do you think that is? Now we aren't getting into that part on this zip line problem yet, but in the future, it's going to get harder. This problem's going to get a lot harder, okay? But in the ideal world, you're hanging from a zip line, and you usually have like a vest that you're clipped into, and you have this cord that you're zipping on, right? And that cord holds your head away from the line, right? Because otherwise, your hair, right, is going to get all caught up in that, and that would be not fun, right? And a zip line is supposed to be fun, right? So the idea of the zip line is to have about 3 feet, right? So if you have 3 feet plus, let's say you're like Hazen, you're 6'2", right? Okay, or you will be someday, right? Probably next year. Okay, so but you're 6 foot now, right? And so at 6 foot plus 3 feet, that's 9 feet right there. If he's coming down and it's only 7 feet off the ground, his legs are hitting unless he lifts them. You know what I'm saying? And that's not going to be fun at about 60 miles an hour. That's going to hurt. So that's why you keep the zip line up off the ground. Okay? So the idea of keeping the zip line off the ground is the protection of the riders. Okay? So this height, they said, was 15 feet. Now what this also does, if you think about it, what this also does is it sets up, think about this on a graph now. If the ground is here, right? Then you go up 15 feet, plus however high that zip line is, right? Okay, to here. So this is your y axis, right? And this is your x-axis. And so this line for the zip line is brought up not only the height of the zip line itself, but also this extra 15 feet. See what I mean? And that new height becomes your b, for your y equals mx plus b. So this b is 15 plus the height of the zip line. Okay? 15 plus the height of the zip line. So to be able to find b, I got to find the height of the zip line. Do I know what m is already? Do I know the slope of the zip line? Yes. That was the first thing we figured out from just the ratio. And this is what I need you guys to focus on, because there's problems like this on the state test, on the ACTs, right? And definitely on my midterm and final, that are going to ask you this. And as soon as you start seeing ratios, you should be understanding that that's a rate of change. Okay? And so, using that as a slope. Okay? But you have to figure out, is it positive or negative? Okay? And in the reality of a zip line, it's always going to be negative because you're always zipping down. Does that make sense? So, this slope is actually figured out. We already said that m is equal to negative 3/4. So I have m, all I need is b. So if I can figure out this height and add it to 15, I'll be okay. Can you grab them, the papers? Because I don't want to stop this. All right, so I guess what I'm saying is, let's figure out the height then. Okay? Now we know that these are similar triangles, right? The reason we know they're similar triangles is this angle is the same on both of these. This angle is the same. And if two angles are the same, then the third angle has to be the same, right? So that means this angle has to be the same as this one. So once we know that it's angle, 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 we know that it's similar triangle, right? It may not be a 30, 60, 90 triangle, but we know it's a similar triangle. So we know there's a proportionality between the lines, right? We know that there's a ratio of this 10 to this 4, right? So there's two ways we can set this ratio up, right? We can say that, and if we're going to call this h, right, for height, we could say that h is to -3, right? And in this case, I would use just 3, just the positive, because we're talking about just going up, okay, just the distance. And distance is always the absolute value. So let's just talk about the distance. So it's it's a 3 feet down here, and right here we don't know how many feet. Okay? Now the big triangle was the H, right? So that means that this big triangle is the 100. Okay? So you got the big triangle versus the small triangle, right? And you're saying that this height is to this 3 as this length is to this 4, right? Now that's one way to set it up. And this is proportionality. These are proportions. Okay? The ratio part says, hey, I know that some number, I don't know what number, so I'm going to call it alpha. I know some number, alpha, times 4 is going to get me 100. Okay? So that's the ratio part. So the ratio part says, hey, I need to use some kind of letter that I don't have up here. So I don't want to use X or Y. I don't want to use, because that's my linear equation stuff, right? I don't want to use H. So I created that alpha. All right? So I'm saying some number times 4 is going to give me 100. Does anyone know something times 4 is 100? What times 4 is 100? Right? So it's pretty easy, right? The math is easy. Setting it up and running the solutions is not. So these are two different ways to do the same thing, okay? So what's your first step over here? You're going to divide by 4. You're going to divide by 4. And like you said, you get alpha is equal to 25. That is your ratio. Okay? This is your ratio that you found using division property of equality. Okay? Now, on this side, what would be my first step? What would I do over here as my first step? How did I get H alone? Multiply, right? Not cross multiply, just multiply. Just multiply by 100. But what I do to one side, you got to do to the other, right? And all that is multiplication, right? Okay? So that is multiplication, property of equality. Right? Okay? And so here, these cancel, and now I get H is equal to 3 times 100 over 4. Okay? I didn't simplify it anymore. I could have, but I didn't want to do too much simplification first. I wanted to just get you to that step. Okay, come back to this side. I said, okay, I know a ratio. I know this ratio, 25 times 4 is going to give me 100. So what am I going to do that 25 with the 3 in order to get H? What do I do? Anyone? Someone? One. Would 25 times 4 give me 100? Yeah, because that's the ratio, right? It's 25 times bigger than 4. Does that make sense? So that means this height is 25 times bigger than this height. What's this height? 3, right? So what's 25 times 3? 75. Good. So you set it up as 3 times alpha, which is the ratio, is going to equal, it's going to equal your actual H. Okay? And at that point, you substitute in. So this is your definition of a ratio, right? Definition, let me rewrite that and a little bit smaller. Definition of a ratio is saying, hey, if I do this times this to get this, then I go this times this to get that. That's it. Okay, the same thing, the same ratio. And so all I got to do now is substitute in the 25. So 25 is alpha, so I go 3 times 75 equals H. And then that is substitution. And then my last is, well, the times is, what is that? 150 plus 75, so 225. Is that right? 225? Does that make sense? So what is 3 times 7? 3 times 7? 21?
Yeah.
Right? Okay, so that would be 210, right? Plus 3 times 5. 15. So what's 15 and 210? 225. Okay? Alright, so we found H. Okay? Now let's find H on this side. Can 4 go into 100?
No. Yes.
Yes. How many times?
2. 4.
Four?
I don't know.
How many times does 4 go into 100?
8.
25. Thank you. How many quarters are in a dollar?
You know.
4. Like 4 times 25, right? 4 25s. Okay? So that's all that is simplify and then distribution. So we get H is equal to 3 times. That's not right. 75. That's not right. Is it? Well, that would be right. How did I get 225? Oh, because I threw in 25. I threw in 75, not 25. So this would be 75, duh. And this would be 75 because I'm not throwing in 75. Sorry, getting my math messed up here in my head. I'm saying, hey, I gotta plug in 25, right? So I gotta plug in 25, I get 3 times 25 is 75. Here we get 3 times 25 is 75. They're both the same, so we know that this height is really 75. So how high is the zip line? 75? No, that's how high the zip line is. But how high is it off the whole thing? So this B is equal to what? B is equal to 15 plus H, right? The definition of the y-intercept, right? The definition of the y-intercept.
Literally saying the same things over and over again.
So what is, how do we solve that? So what's H? 75. So B equals 15 plus 75. That's substitution. And what's 15 plus 75? 90. So, and that is simplifying. And you don't have to do this. You can choose one of these sides. I don't care. You don't have to do both sides. But you want to find the side the way you